Hey everyone, and welcome at our first episode of the Global AI Notes. Well, as you might have noticed, GPT, OpenAI, large language models, we cannot think about without them anymore. So, in this episode, we will discuss actually a part of it. We will talk about vector search and embedding. My name is Sami Depre. I'll be your host today, and I'm welcoming you to this show. Well, and without a nice guest, we cannot talk. We cannot have a talk show. So I'm glad to have our first guest in our show, Farzad. Farzad, thank you very much for joining. Maybe you can start with introducing yourself.
Yeah. Hey, everybody. Glad to be here. Thank you so much. My name is Farzad Sunavala. I am a senior product manager at Microsoft, working on Azure Cognitive Search. And more particularly, the past 6 months, I've had the pleasure of working on probably our most in-demand feature called vector search. So really excited that that's now in public preview and excited to talk about vectors today.
I can imagine it's really a nice product. I've paid it with it myself also. I've been implementing it also with a customer. How did large language models for you change your life?
It changed my life in a lot of ways to the point where I honestly do use it every day, whether it's debugging Python code, which I'll actually show later in the show, or whether it's just finding information about. I just booked a holiday to Greece, and I got a lot of really helpful tips from some of these large language models. So it's changed my life for the better. There's a lot of really good things from a productivity perspective and just information retrieval perspective. And I think it has so much more potential.
Yeah. How could you say that document retrieval is really linked to large language models has really changed it to a different level?
Yeah, so that's kind of going to the kind of the more emerging term, or I won't really say emerging, it's been around for a while, but this kind of pattern called retrieval augmented generation. And this is a really common design pattern for, I'm going to say customers, but really just people and organizations around the world who essentially have their own data and they want a large language model to understand it. Or in other words, like chat GPT on your own data. And so document retrieval, or the R inside of that RAG or retrieval augmented generation pattern, is so critical. And a lot of times you trust that retriever to retrieve from something like a search engine, in this case, a vector search engine, in the kind of more modern ways of retrieving the most relevant documents. And the reason why that's a thing is because every model in the world, everyone here has probably gotten rate limited or token limited at some point in their lives playing with large language models. And that's really important to have a good quality retriever so you can pass in the context from your own data or your own documents into some sort of downstream application or large language model in most cases.
Okay, very interesting. And if I'm correct, that's actually what you want to show us today, right?
Exactly.
All right. I'm looking forward to learn a bit more about it. So I'll give the platform to you, to the audience who is listening on LinkedIn, on YouTube, or wherever you're watching. Please don't, please make use of the chat functionality with your questions so we can use them after the session. So, Farzad, the platform is yours.
All right, let me go ahead and share my screen. Can I just get an ack if someone can see it, or
It's
Sammy?
showing.
It's showing. Awesome, good stuff. So I'll pretty much just start out talking about the product for the feature that I've been working on is Azure Cognitive Search. So I'm going to start kind of just giving a very quick elevator pitch of kind of what Azure Cognitive Search is, kind of why it's important, some common use cases, and then talk about the vector capabilities inside of Cognitive Search that we recently launched. So let me quickly move to the next slide. So here are some common applications of Azure Cognitive Search. For those of you who may not know, the one-liner is Azure Cognitive Search is a platform as a service on Microsoft Azure. A lot of people actually call us a search as a service. Pretty cool term that essentially allows you to do enable all these different scenarios. A really common one is just the general kind of workplace search where Customers, people, organizations just have a bunch of files, whether it's in SharePoint, blob storage, SQL, structured data, maybe, and you just have a search bar and you just want to find the right document. That's what workplace search is all about. Then we also partner with a lot of ISVs and vendors who like using cognitive search because it's super quick and super rapid to build market-ready applications for their customers. We also have a lot of e-commerce customers where people actually use cognitive search to actually power their e-commerce engine or service, that with the ultimate goal of a consumer buying their product or service. So relevance and latency, super, super important here. And then just the general kind of website search. Anytime, whether it's a government website or anything, there's a search bar and you just need a really simple and easy way with the filters and facets just to get information to your website. We support that as well. Here's just a quick screenshot of kind of what Azure Cognitive Search looks like in the Azure portal, as well as some of my favorite features that you see here, such as semantic search. We'll talk more about that. Keyword search. I'm a huge believer that in most information retrieval and large language model use cases, keyword search is actually so important inside of your retrieval layer in the RAG pattern. We'll talk about that in a little bit. Fascinating language analyzers, all the stuff that you could ask for inside of a search engine to build on top of. Cognitive search has you covered. So let's talk about kind of the hot thing. Oh, my mouse doesn't want to work today. There we go. So what about generative AI scenarios? So this is kind of where all the fun is and all the red hot stuff in terms of large language models, vector databases, GPT, all this cool stuff. So I'm going to show this quick slide, and actually everything on here are things that I've actually used. When Sammy asked me, what do you use large language models and how has it changed your life? These are actual prompts that I've physically done. Especially I'll laugh about, I was playing Xbox the other day and it just completely quit working on me. And I actually went to GPT to try and troubleshoot how to fix my Xbox. It's still broken, unfortunately, but that's another problem. But there's so many different things you can do with these things called prompts, whether it's writing a tagline for an ice cream shop, troubleshooting your Xbox. As I said, I actually use it for debugging and sometimes even writing when I get lazy Python code snippets that I may have forgotten from a long time ago. And then I know image generation is a huge cool thing now with AI generated images. You can do that using tools like DALL-E 2 as well. So really, really cool. This content creation by API, absolutely game changing. I'll quickly talk about the key terms you kind of need to know. And the reason why I'm going to spend a little bit of time on this is because before you actually understand the concept of vector databases or vector search or vector-based retrieval, it's kind of important to know how in most scenarios in this kind of large language model pattern, kind of key terms that play a pretty critical role. And it's also kind of analogous with vectors as well. So in this case, you have your prompt. Everyone talks about prompt engineering. So all this is in a one-liner is the text you send to your service in the form of, most of the time in the forms of an API call. And so this text is just the input into that large language model. And so then you get what's called the completion. And so this completion is essentially the output that, in this case, I'm using GPT, generates based upon whatever your input may be. And then there's that beautiful token limit that everyone's talked about recently, the tokens. And so these are how these transformer models essentially compute and understand information. It's by generating these processing tokens, in this case, in the forms of partial or full words that are processed by these GPT models. So these are probably the most important words you kind of need to know when it comes to kind of generative AI. And so, as I mentioned, what is the kind of problem? Like generative AI doesn't have context for your data. It doesn't know anything about it. So a lot of times, if you ask something very personal to an LLM, well, I know there's the whole topic of hallucinations, but in most cases, if you have a pretty robust prompt or ask something very, very personalized, like does my health plan cover annual eye exams? You're most likely going to get a response like, I'm an AI language model and I don't have access to your specific information about your health plan. And so that isn't really helpful for me if I want to use LLMs to change my life for the better. And so what is the kind of solution to this? It's this pattern called retrieval augmented generation. And so there's a lot of different patterns for this. Here's kind of my go-to one using cognitive search and Azure OpenAI, specifically cognitive search as the retriever, and then Azure OpenAI for the actual generation of a generative AI response. So it starts on the left-hand side where you have your app UX, your mobile, your web app, whatever it may be. Then you have some sort of orchestrator, something that kind of puts all these puzzle pieces together. And in most cases, you'll have, let's quickly jump to the right-hand side. Well, you have your data sources. Your data sources could be in blob storage, SQL, PDFs, in memory, whatever it may be. And so once you have these data sources, I'm not going to like deep dive into kind of what a vector really is, but in a one-liner, a vector is just kind of a universal representation of your data. And so it's a essentially looks just like how I have on the screen. It's just an array of numbers, array of strings in most cases. And so it's really cool because Azure OpenAI and a lot of these transformer models, and really realistically the past year made it super, super easy for developers and pretty much anyone to just call a REST API endpoint and get these embeddings from your own data. Where if you ask me, not even 3 years ago, probably 2 years ago, it was really, really difficult to train your own embedding model, call it, host it, all that good stuff. Now it's just super, super easy with kind of the emergence of LLMs. And so then once you have those embeddings, Cognitive Search now serves as a vector database as well, in addition to full text search. So now you can store those vector representations of your data in Cognitive Search. And then you can take advantage of Cognitive Search's advanced search retrieval mechanisms to ultimately get the most relevant documents or vector representations of your data using algorithms like approximate nearest neighbor, and pass in those top 1, 3, 5, 10, however many, maybe max out the entire Azure OpenAI, or in this case, I'll just talk about GPT-4, your GPT-4 call to do the what's called grounding your LLM. You're giving it the information that you want for you to get the best possible generative AI answer back that's still relevant to you. So here's kind of a quick example where you can combine your data with prompts. Is a really powerful concept. So in this case, you have a prompt. You ask a question and you actually see sources to the question. Having sources is actually really, really important, especially in this world today where everything is about trust. You really want to make sure that the data you get back from LLM, it's not hallucinating and it has actual sources that maybe I could click into this PDF, read if I want to deep dive into a certain thing about my healthcare plan. I can understand all that. So I think that's really, really, really powerful. Excuse me. So how does this all kind of play in with vector search? So enhancing RAG with advanced retrieval features. The R is bolded here in RAG for a reason, and I'll say it again. Putting emphasis on the quality of your retriever is so, so, so important. And evaluating, iterating, and testing your vector search algorithms, your quality of your embeddings, all this good stuff is super, super important when you have a RAG application or a chat on your own data using large language model scenario. And so Azure Cognitive Search is best committed to providing the best retrieval solution through our newest and my favorite vector search capabilities. I'll talk about hybrid search and where the real value add for that really is. Filtering, everyone talks about filtering, whether it's for optimizing your search performance, giving a better UX, maybe security filter trimming. We support a very comprehensive modes of filtering in cognitive search. There's this concept for those of you who may have used cognitive search in the past called semantic search, a premium add-on feature that we have. A lot of our experiments showed that actually re-ranking your vector search results actually gives you even better relevance. So we'll talk about that a little bit. And then coming very, very soon, I'll give everyone here a sneak peek, is we're actually going to have an integrated vectorization feature where you can literally just throw in documents, 1,000-page PDF, run your indexer. It'll automatically chunk it to fit within those context token windows for your embedding model, and then pass it straight into cognitive search, and you can do your vector retrieval. You don't have to worry about doing all this on your own in a Jupyter notebook or something. We'll manage all that for you. So really, really exciting. So I guess I'll stop there, and I guess Sammy, or if there's any questions we want to take on RAG before we kind of dive into kind of how to get started using vectors and kind of what they are.
There's no questions at the moment, so you can just go on.
Alrighty, let's do it. My mouse really is acting up today. All right, so how might we take our enterprise search or RAG scenarios to the next level? So this is what vector search is all about. So I'm really happy to announce that vector search is now available in cognitive search today. So what is vector search and kind of what does it really allow you to do? We'll talk about that. But at a very high level, the pitch I give is really revolutionizes the indexing experience in cognitive search and powers your retrieval augmented generation for large language model applications. Since everyone today wants to use a large language model, particularly on their own data, vectors are so powerful. And if you want things like deploying it at scale, using it with a very large scale data set, security, Azure Cognitive Search is the product for you. And so we support multiple different things. Now that we have vectors, historically people and customers just use us as kind of a full text search engine. Now we support things like image search, audio search, video search, graph structures, and of course, text search. So multiple different mediums of data. Ultimately, you could leverage data from any data store. There's two ways to kind of get data into your cognitive search index. Via the indexer, and I'll talk about that as well, or just the general way that you would do it with any vector database, just upserting via a what we call a push REST API. Ultimately, we have a very comprehensive and advanced retrieval modes that ultimately, like I talked about, hybrid search. So you can ultimately improve your relevancy by not just using vectors alone, but combining it with the power of keyword search, as well as semantic re-ranking that powers Microsoft Bing today, which I think is a really powerful combination. And then again, just for those of you who work with large enterprises or data security and scale is really important to you, we're an Azure AI service. We sit in the Azure AI platform, and you get all the security benefits you would with an enterprise-grade cloud service. So whether it's private endpoint support, CMK encryption, whatever it might be, we're gonna be able to support your enterprise-grade security needs, as well as scale. If one day you maybe only have 100 documents and you deploy it, to 10 other countries and they want to add their 100 documents, and every single day or week or month, your workload just constantly keeps changing, we can support that. So really happy to announce vector search capabilities in Azure today. So with that, I'm going to quickly go into talking about kind of what is vector search, and kind of how this new capability kind of really fits the picture. So as I said, kind of in the previous retrieval augmented generation example, think of this as like the more zoomed in experience on the cognitive search experience. So you have your data sources, just like I mentioned previously. Once you have your data sources, you can convert them into vector representations where distances essentially in the vectors represent similarity, okay? And so once you have your data sources, you can use models like Azure OpenAI text embedding ADA002. Personally, my favorite, it's what I use. It's a sister team of ours, works really well for text embeddings. And so if you have a bunch of text, whether it's in PowerPoint, Word, PDF, whatever, JSON, you can go ahead and crack that however you may want. Or if I just have it in plain text, I can just use the push API to call it and generate vector representations of my data. So once I have these vector representations of my data, I pretty much just throw it into cognitive search, because now cognitive search can store and retrieve and do advanced search over vectors. And so we use this approach called approximate nearest neighbor. And essentially in a one-liner, all that really is, it's just a vector index algorithm. Some of you may have heard of KNN, which is like kind of the more brute force approach of finding the exact nearest neighbors in an algorithm. For most of our customers, approximate nearest neighbor, and it's, I think, the most common one in kind of the vector database and vector search industry today. We use an algorithm called HNSW, or hierarchical navigable small worlds. I really wish that was easier to say, but that's what we use today. And very soon we'll also be supporting exhaustive KNN. So for those of you who may have smaller data sets but may really want better accuracy, you could also perform and find the true k-nearest neighbors rather than just an approximation. But in most kind of large general use cases, approximate nearest neighbor is kind of the best bang for your buck in terms of performance and speed, or performance and recall and relevance. So then once you have your ANN algorithm and your vectors inside of your index, all you have to do is, just like how you pass search and use algorithms like BM25 for full text search, all you do is now pass in your query embedding into cognitive search and we'll do the approximate nearest neighbor search on your vector retrieval and give you the results based upon whatever similarity function you define. In most cases, we see cosine similarity. And so that's essentially how vector search works from an end user flow perspective. And so I think this is really, really cool because this is really a story of how you bring kind of traditional search together as well with the power of artificial intelligence, and really combining them to ultimately provide a really, really cool product and just end user experience. So with that, I probably should have started with this in hindsight, but I'm going to go ahead and kind of give kind of a very high level description of what vector search is. For context, I was talking to my nephew actually not the other day, I believe it was sometime last month. And he asked me what I do for a living. And I said, oh, I work on vector search for Microsoft. And he was like, huh, like what's vector search? And for context, my nephew's in 5th grade. And my nephew loves to read books. And so I'm like, huh, okay, how can I give an analogy of what I do for someone in the 5th grade who really loves books? So at a very, very high level, think about vector search like this. You're inside of a library. And I actually reminisce back to my university days, and my library was very disorganized. I was very, very old, books everywhere, wasn't categorized in the best way. And so a lot of times it was quite frustrating. And so imagine you're in a library with books just scattered everywhere. And we know in libraries that each book contains unique insights, themes, genres, whatever it might be. And so my personal challenge was finding a book inside of the library in my university was really challenging. And to the point it was actually time consuming to actually find the exact book I wanted. Okay, so you have all these books of different themes, colors, whatever, dates, publishers, all over the place. And so I thought, okay, what's kind of a good solution to this? So imagine there's a skilled librarian. And in my case, I was really lucky to have a very nice lady who knew everything about the library. And when I said, hey, I want you to go give me a book about, World War II, she would immediately know where to go, ask me the questions I need, and find the book very, very fast. And she connected me with kind of the similar different topics of that desired book that I wanted to find. And so that's kind of how vector search kind of is at a high level. Imagine that this vector search is that skilled librarian that makes you find that book, that similar book that I wanted, or in some case, the exact book that I really wanted, very, very fast and accurately. And so now let's all pretend we're actually complete AI geeks. So let's deep dive into what vector search is. Imagine you're in this scenario where you just want to efficiently retrieve semantically similar items from similar large-scale data sets. So I'm talking about maybe gigabytes, maybe terabytes, maybe even more than that worth of data, and you want to effectively search over it. And when I say effectively search, I actually mean more like a semantic search. So how can you actually understand the user intent? Or maybe it's multiple languages, or maybe multiple mediums. And so the challenge a lot of us face kind of historically is sifting through these large scale databases to find the right document or find the right answer. A lot of times is really challenging and actually computationally expensive. And so what is the scenario to that? This is where vector search kind of comes in. Using algorithms like approximate nearest neighbor to actually calculate the cosine similarity or the vector differences in a very, very high dimensional vector space, which is essentially the output of a lot of these embedding models that we see today, like Azure OpenAI's text embedding 8002. And so with that, how can you kind of get started? So there's a high level flow, and then I'm actually going to dive into some code. So step one, as I mentioned earlier, ingest your data sources, generate your document embeddings, add them to your indexes. Multiple ways to do that, either via a more orchestration pipeline that we have called our indexer, which allows you to pull from different Azure data sources, and you can add all these custom skills, AI skills, through other kind of Azure AI services that we have, like computer vision, or forms recognizer, or the kind of my way to kind of get started very quick and easily is just spinning up a Jupyter notebook and using the push API. And I'll show an example of that in a bit. Then creating your vector configuration. This is, for the most part, when I'm starting out, I typically recommend just going with the defaults. We put a lot of effort into configuring our HNSW algorithm defaults and our cosine similarity algorithm. go ahead and go for that. And depending upon the embedding model you're using, it may have recommendations on what parameters to choose. But in general, stick to the defaults that we have today. And we're constantly going to be adding more to this vector configuration so customers can further kind of fine tune their relevance and latency and ultimately their vector experience. And then all you have to do is generate your query embedding inside of your client-side user app, whatever it may be. And then you get your results set. And that's super, super important because when it comes to the concepts of RAG, getting really, really accurate results are super important. And so I think with that, I think I have one more slide I wanted to touch on. So another kind of unique selling point, I think, of cognitive search is that we do have this feature called hybrid search. And so as I mentioned earlier, full text search is really, really good at certain things, but vector search is also really good at certain things. And so a lot of times, sometimes I talk to people and they're querying a cognitive search index and they're doing vector retrieval, but they're querying things like product IDs or ISBN book numbers or timestamps. And I'm like, vector represents vectors aren't really going to perform that well when you're only querying like things that have more of a sense of a full text search. In that case, this BM25 or full text search algorithm is going to perform really, really well. But a lot of times, most customers kind of don't know what their end user base is doing. And a lot of times it's just a mixed bag of queries. And so that's where hybrid search kind of comes into play, where you get the benefit of both kind of your full text search experience, because that's what cognitive search historically was, as well as your vector index. We use an approach called reciprocal rank fusion and combine both approaches together. Super, super, super powerful. Highly, highly recommend checking out hybrid search. It's majority of the time, if not all the time, is going to give you better retrieval when it comes to large language model applications and powering your documents into them. And lastly, before I go to the code, this is the last slide. Achieve better relevance with hybrid search plus semantic re-ranking. So I think this is really, really, really cool. You get the benefit of full text search. You can get the benefit of something like Azure OpenAI or OpenAI text embeddings 8002. So getting a really good dense representation of your data. And then also, as I mentioned earlier, we have a semantic search feature that one of the features of this semantic search feature is semantic re-ranking. So it actually takes the top 50 documents from your either full text or vector or hybrid retrieval, and it re-ranks them using a deep learning technology that actually is from the same family of models that power Microsoft Bing today. And I think that's so powerful. And this approach has actually yielded really, really, really good relevance. And we'll have a blog post coming out showing our experiments and actually quantitatively how much better the relevance and retrieval quality really is with this hybrid search plus semantic re-ranking approach. So be on the lookout for that. So with that, I guess let's quickly do a time check, Sammy. How we doing? I'd love to show some code samples.
Time is getting limited because we like to keep it within 30 minutes, but I think let's go still to one demo and some code. If you can show us, that would be a nice closure.
Yeah, let's do it. All right, let me quickly switch my screens. I'm going to do this in less than 60 seconds because I think that's all I need. All right.
Gone in 60 seconds.
All right, let me go ahead and share my screen. And let's go 60 seconds starting now. So you can get started with vector search and all these different code samples I have here. So if you just go to GitHub, I'll probably, when this gets posted or if someone wants to send it in the chat, if you've already accessed it, the cognitive search preview repository, we have a bunch of different code samples. Everyone's asking for Python nowadays, so I'll go ahead and go into Python. For those of you who are interested, I know I just recently published a LangChain sample. We actually have cognitive search as a retriever and a vector store on LangChain. So if you want to go ahead and use LangChain with Azure Search as your vector store or just retriever in general, you can definitely use it then. So I'm going to quickly just walk through this one. It's a very hello world example of how to get started. I pretty much have some documents here. You install the Azure Search Documents SDK. I'm using OpenAI embeddings. I just import some libraries I need, some environment variables. I have a text JSON sample of a bunch of Azure services with ID, title, content, description, and category. I'm generating dense vectors for them, title vector, content vector. I create my search index, so just creating my schema and my vector fields over here, my vector configuration that I talked about. Optionally, you can do a semantic configuration. insert them with literally just a couple lines of code. Bam, I uploaded 108 documents with my vector representations. And now if I actually want to do a vector similarity search, in this case, I did tools for software development. Here's essentially my request body, printing the results. I get Azure DevOps. I get my cosine similarity score pretty high, as well as the content. And if you want, you could actually show the actual raw embeddings if you want. In this case, just for UI purposes, I kept it simple. So highly recommend. I think I'll stop there. Here are all the code samples, bunch of Jupyter notebooks and .NET, JavaScript, and Python. We have a lot of good stuff coming at you very, very soon. So be on the lookout and stay tuned to our Azure Search channels.
Great. Thank you very much, Farzad. So to recap it, Azure Search has implemented a way to add vectors in it. And so vectors are actually your text or images or audios that has been converted into numbers. Those numbers have a certain natural language meaning. And then based on mathematical solutions, we can actually see which documents are most similar to the query that you're actually asking, correct? All right, cool. Well, I would tell everyone just try it out and see if it can fit the solutions that you're building. If you're building, for example, chatbots technology, then with the GPT models, then for sure you need to have a look at that to be able to ask questions on your own data, right? Okay. Well, Farzad, I want to thank you very much for your time, for the very interesting session. No specific questions came from the public, but we'll see. If they have any questions, they can reach you on Twitter or on LinkedIn, send you a message there. Don't hesitate also to send those questions to the Global AI community, and then we'll forward them. Next week, we will have another session, and we'll go a little bit more back to the basics of actually what we've been learning today. I will go more about how transformer and foundation models are actually working. So tune in next week, same day, but not same time. So we'll be doing this now at 10 a.m. in the morning, well, European time, and we'll be switching every other week. So you will always find the latest on our Twitter, on our LinkedIn channel. So please follow us there, on our YouTube channel, where you also will get the details. So wherever you are, thank you for joining. Still have a good day, have a good evening, and hope to see you next time. Don't forget to tune in. Bye bye.